Okay, for the second topic, we're going to be looking at one of the actual other ways to solve systems of equations. So you can solve system of equations using different methods. What you're going to end up eventually doing is determining what the easiest method is for you to solve the problem. So what you're going to see about this one is we can solve systems by using what's called substitution. Okay, so here we go. It's kind of a multi-step process here, but it's really not too bad. It says, first of all, identify the equation that has an isolated variable. So you're looking for one that looks like y equals or x equals with stuff on the other side. So one variable that's by itself. Substitute. You're actually going to put the equation in step one that looks like y equals or x equals and plug it into the other equation for that variable. So we're substituting y for something else, or x for something else. Then you solve the equation, essentially getting the other variable by itself. Plugging back in to find the other variable. Okay, so we're going to check to find the other part of the answer. And then at the end, like we did with graphing, we're going to check our solution. So we're going to substitute our ordered pair into both equations, just like we did with graphing. Okay, so here's an example. Solve the system using substitution. Okay, so as you can see, I've identified this one on the bottom here as y equals 3 plus x. So that's kind of by itself. So we've already checked off step one. We already have an equation solved for one variable. So what I'm going to do is I'm going to take y equals 3 plus x. I'm going to put in parentheses. It's a good idea to think of y equals this whole thing, 3 plus x, and substitute it in for y. So where I see y in the first equation, I'm going to replace that whole y with 3 plus x. So it's going to look something like this. X plus parentheses 3 plus x equals 5. All right, so that's step 2. Now I'm going to do step 3, solve the equation. Notice I have x's and 3's I have to solve and get x by itself. So that is 2x's plus 3 equals 5. 2x equals 2 when I subtract the 3, and then dividing by 2 gives me x equals 1. Okay, so I got one of my two answers. Plug back in to find the other variable. Now what I always do is I take my answer for the variable I just got, and I plug it into the one that's by itself. As you can see, y equals 3 plus x. If I just found out x, I can easily now find y. So y is equal to 3 plus 1, which is 4. So my solution should be 1 comma 4. I can do a quick check to make sure that's true. So I'm going to go back to both original equations, x plus y equals 5. So that'll be 1 plus 4 equals 5. That checks. And then y equals 3 plus x would become 4 equals 3 plus 1. Since they both check, I know this is my solution. Okay, so now here's a couple more examples. Just going to kind of continue on with this process here. Solve the system using substitution. Okay, so let's see. X equals 7 minus 3y. So this one's done, isolated, ready to go. I'm going to replace that whole thing in for x right here. So we just have to be careful how this looks. It's 4 times 7 minus 3y minus 2y equals 0. So notice I'm just literally taking this whole thing and replacing it here for x. Now I'm going to have to distribute. So that's 28 minus 12y minus 2y equals 0. All right, continuing on. Combine like terms. So 28 minus 14y equals 0. All right, I'm almost there. I'm going to, let's see, I can add 14y on the other side. So 28 is 14y. And then divide by 14. That'll get me y is 2. Now that's not the final answer. I have to take my 2 and plug it back in. So I'm going to plug it into the x equals above. So x equals 7 minus 3 times 2. Well, that's 7 minus 6, which is 1. So my answer should be 1 comma 2. I can check it really quick. So I'm going to plug it into both of these here on the top. 1 equals 7 minus 3 times 2. That's true. And 4 times 1 minus 2 times 2 equals 0. That's also true. So I know this is my answer. Okay, similarly here, I noticed that both of them are equal, y equals, they're both isolated. So this is kind of a sort of a different way of looking at it. What we're going to do here is essentially set this guy equal to this one. If they're both equal to y, then they should both be equal to each other. So I'm going to say 3x plus 4, you are equal to negative 1/2 x minus 3. And I'm going to try to solve from there. Okay, so I'm going to add 1/2 x to both sides. So I have 3.5 x essentially. And I'm going to subtract 4 on both sides. So that's equal to negative 7. All right, so we're going to have to take negative 7 and divide it by 3.5. All right, that gives us a nice answer at least of negative 2. Now I have a choice. I can plug my negative 2 into this one or into this one, depending on which one I want. I'm going to just plug it into the first one. So I'm going to say, okay, so y equals 3 times negative 2 plus 4. That's negative 6 plus 4, or negative 2. It appears my answer might be negative 2, negative 2. A quick check to verify. I got to plug it into both y equals. So y equals 3 times negative 2. Oops, let's make that not y, sorry. Let's make that negative 2. So negative 2 equals 3 times negative 2 plus 4. Well, 3 times negative 2 is 6 plus 4 is negative 2. That one checks. Plugging it into the other one, negative 2 equals negative 1/2 times negative 2 minus 3. All right, so negative 1/2 times negative 2 is positive 1 minus a 3, negative 2. That one also works. So here are both my solutions.